Let's take a look at equations of lines. So I have a few equations here, and each of these is considered a linear equation in two variables for a couple of reasons. First, they each have two variables, y, x, and x. They're linear because x and y don't have any exponents on them, and there's no denominators, there's no symbols like square roots. By denominator, I mean if x was in the denominator or y was in the denominator, it wouldn't be linear. Here I have 3 in the denominator, and here I have 3 in the denominator. That's okay. So these are each linear. It turns out these are 3 different equations that represent this particular line right here through the points listed above. -6, 2, and 6, -6. One important aspect of a line or an equation in two variables like this that's linear is when you graph it, you end up with what we call a constant slope. So that to get from one point to another, I always move according to the ratio -1/3. Now, in this case, that slope can be viewed 3 different ways. I can view it as -1/3, I can view it as 1/-3, or I can view it as -1/3. Negative divided by a positive is negative, a positive divided by negative is negative. As far as what that tells me to do here is the top number is the vertical change on the graph, and the bottom number represents the horizontal change. We often refer to those as rise and run. So the first version of the slope says from a particular point, drop down 1 unit, and then move right, because that's positive for x, 3. 1, 2, 3. That puts me at that point right there. This version over here tells me to rise +1 vertically and go left because that's a -3. So if I was at this point right here, I could rise 1 and then go left 1, 2, 3, and I'm at another point on this line. Now, how does it relate to the 2 points I started with? Well, the slope is a ratio, so if I keep going down 1/3, down 1/3, down 1/3, I'll eventually get at that other point I had earlier. So consider that to get from this first point to that second point, I had to drop 4 and run 12. And so slope as a ratio in this case means that -4/12 must reduce down to -1/3. This I would consider to be a downhill line because as x moves in a positive direction, if I were walking along and I hit this, I'm going downhill. The first equation I wrote there is what's called slope-intercept form. And that's y equals some number times x plus some other number. And these numbers, m and b, are parameters for this equation. So that we're going to fill those in with something. So like in the previous example, my m was -1/3 and my b was -4. B represents the y-intercept, or at least part of it, the y value. And technically a y-intercept is a point. So that would be the point 0, -4. The other version I had there is what's called the general form for a line. And the general form is some number times x, or y, plus some other number times x equals some third number. And if you look back at that one I had here, I had 3 times y plus 1 times x equals -12. And these numbers, the 3, the 1, and the -12, could be positive, negatives, fraction, decimals, doesn't matter. The last one I listed was called the point slope form. And what that is given a point, x1, sorry, y1 could have been the first point, then, and the slope, m, I need to know those two things, then I can build an equation using the value of the slope and the value of the y-intercept. So that would be y minus whatever the y value of the point is equals the slope times parentheses the variable x minus whatever the x value for that point was. And so here, you'll notice that I have the same slope as I do above here, and I picked the point -6, -2, and I plugged it into that equation. So I'm just going to do that here to demonstrate it. I'm going to have y minus -2 equals -1/3 times x minus -6. And when you subtract the negative, you get a positive. Subtract the negative, you get a positive. So that's why in this equation over here, it's a y plus 2, -1/3, x plus 1/6. So each of these equations, point slope, slope intercept, general equation, or point slope, every one of them actually is this red line right there. So I just gave 3 different versions of that line. So let's see how I came up with that. First thing I want to do is, if I want to determine the equation of a line through 2 points, is I want to graph those 2 points. So I want to find -6, -2, and +6, -6. So there's my 2 points. I want to find the slope in between them, and graphically I like to do it with a drawing. Can you do it without the drawing? Totally. But here I'm specifically asked to graph the line through the points. So there's my 2 points. Here is a line. I'm just going to extend it a little bit. Say right there. Now, the point of a graph is to show all possible solutions. What are the trend to the solutions of an equation? So I have this equation over here, y equals -1/3 x minus 4. Which pairs of x and y make it true? Well, I believe -6, -2 makes it true. I believe 6, -6 makes it true. Over looking at my picture, I can see -3, -3 makes it true. 0, -4 makes it true. 3, -5 makes it true. And then there's some numbers in the middle, like this point right there. Maybe that point is, I'm guessing, negative, try again, negative, yeah, -4 1/3 for x, comma, no, I got that wrong. Try again. Erase. That point is 1 for x, -4 1/3 for y. So if I plug in 1 for x here, I'll find the y value is -4 1/3. Check it if you wish. So this line represents all solutions. It's a good idea to put arrows on the end indicating it continues that pattern up to the left and this pattern down to the right. To find the equation of this right here, I want to see what is the rise and the run to get from one point to another. And I usually draw that in to make it easier to count. So here I can see I'm going down 1, 2, 3, 4. So I dropped 4. And then going this way, I've got 1, 2, 3, 4, 5, 6, and then another 6 to get to there. So I'm going positive 12 to the right. So the slope here would be rise -4 over 12, and always reduce that if possible. And usually don't want to turn it into a decimal. In this case, I get -1/3, which is a pain as a decimal because of that repeating 3. Okay? So in this case, I wanted to graph the line through the points. Check, I did that. I wanted to state the slope as a reduced fraction. I did that. Just for fun, I'm going to come up with the equation. A couple of ways to do that. My favorite equation is that slope-intercept version. So if I know the slope and I know the y-intercept, then I can find the equation. M is the slope. B is the y value of the y-intercept. And it looks like it hits there at -4. So I'm just going to believe it does for now, and I'll double check it later. So I believe the equation is y equals the slope, negative 1/3, times x, and then plus -4, or you could write that as -4. I think that's the equation for this line. So I'm going above and beyond what I was asked for. To double check that, I'm going to plug in, say, that x value right there, and see if I end up with that y value, the -2. So checking my equation to find y, if x is -6, I just have to complete this arithmetic. So negative times a negative is a positive. 1/3 of 6 is 2. So I get 2 minus 4 there. And 2 minus 4 on a good day is -2. So this equation says that if x is -6, y has to be -2. And that does check with the given information. Okay? So I'm pretty sure I have the right equation for that line I drew. All right, let's try another problem. On this one right here, oops, I think I skipped. There we go. I want to find the x and the y-intercepts for this equation right here. So there's a variety of ways to do that. An x-intercept is on the x-axis. So if I were to kind of sketch some x and y axes here, if I'm on the x-axis, I've not gone up nor down. So that means the x-intercept is the point. I got to find x, but y has to be 0. And y is 0 because I haven't gone up or down. So just a note about that. There's an equation for the x-axis. It's the line y equals 0. Every point on the x-axis, y is 0, x is whatever it is, maybe 1, 2, 3, 4, 4.5, 5, 6, and so on. So I got to figure out what number that is. So to find the x-intercept, just plug in y equals 0 to the equation. So that's going to give me -5x plus 7 times 0 equals 140. Well, 7 times 0 is 0, so that term's gone. I just need to break that multiplication by dividing by -5. 5 goes in there. So let's see, positive over negative is a negative number, and x goes into 140 how many times? Let's see, it goes into 14 twice with 4 left over, and it goes into 48 times. So x goes in there -28. So if I were graphing this, and let's say I was jumping that this was, oops, go the other way, 10, 20, 30, then I just found my x-intercept is about right there. All right, the y-intercept is pretty similar. The y-intercept is on the y-axis. If you are on the y-axis somewhere, you've neither gone left nor right, so x has to be 0. So I'm looking for the point 0, some number. Okay? The y-axis is the line x equals 0. Because on the y-axis, you haven't gone left or right, so x is 0 and y is whatever that number we're at is. So if I come up here and I plug in x equals 0, that term's going to disappear, and I'm going to end up with 7y equals 140. Breaking multiplication, divide both sides by 7, and you're going to get y equals 20. So let's say that's about 20 right there. So that point is my y-intercept. And if I have 2 points, I have a line. It's always a good idea to check, but I'm just going to graph it for now. I'm pretty sure that's my line. I wasn't asked for that, but just for fun. And remember, the vertical axis is always the y-axis, and the horizontal axis is always the x-axis. So my intercepts are, let's finish this off, -28, 0, and 0, 20. So those are my answers. or the intercepts. Let's try another. Find the equation in terms of x of the line that goes through those points. Always a good idea to graph in a situation like this because that'll help you figure it out better. So although I wasn't asked to graph, I'm going to do it anyway. So I'm going to go steal a graph here. Let's see. Back in here. Oops. What did I do? Try that again. Kind of got it there. We'll just cover that part up. Somehow. Okay. So let's see. -5, -1, there's 1 point, and the other point is 4, 3. And I strongly believe that plotting those points makes this way easier. From here, I want to figure out how to get from one point to another. So I got to rise up, looks like about 4, and I have to run, looks like about 10. Get that right. So let's see, -5, -1, +4, 3, and I'm going up 1, 2, 3, 4. And then I'm going to the right, 5 and another 5, no, 5 and 9, 5 and 4, 9 altogether, right? So on my line, which goes through those points, extend that a touch, something like that. It looks like the slope is 4/9. The y-intercept looks like it might be 1, but it's a little off there. So either I didn't graph straight or I'm a little shy. Okay, I'm not clear about that. So I'm going to have to test that out a different way. So far, my general idea is to find something that looks like this. And I've just found what I believe to be the slope, but I'm not sure what the y-intercept is. So what I'm going to do is just plug in some information. So I'm going to plug in this slope and this point. 4 is my x value, 3 is my y value. So if I come over here, y is 3, m is 4/9, and x is 4. I don't know what b is, but look at now b is the only thing missing. I can solve for it. So 4/9 times 4 is 16/9, right? Multiplying fractions, you multiply across numerator, denominator. Common denominator is irrelevant. So 3 equals that plus b. Since it's connected by addition and it's positive, I'm going to subtract 16/9 to both sides. So now I got to figure out what is 3 minus 16/9. So let's see, I'm going to have to look at that as 3/1. And then I'm going to multiply top and bottom by 9 to get a common denominator. That's going to give me 27 minus 16/9. 27 minus 16 is what, 11? Which is a little bigger than 1. So I'll buy that. That looks like about 11/9 right there. Because 1 would be 9/9, 2 would be 18/9. Yeah, okay. So it looks like my equation is y equals 4/9 times x plus 11/9. And you could write those as mixed numbers, but I recommend not doing that. Improper fractions are generally better. Now, this is kind of crazy looking. It's got some fractions, not too bad. I should double check. Now, since I used this point over here to find the y-intercept, I should use this point right here to check. And the check is kind of like what we did before. We're going to plug in the -5 and pray -1 pops out. So let's do that. So I think this is the answer for that problem, but I want to make sure. So what does y equal if I plug in -5? So common denominator, oh, we don't need a common denominator, but we're going to get one. We're multiplying here, multiply across top and bottom. 4 times -5 is -20 over 9 plus 11 over 9. 20 minus 11 is 9, so -20 plus 11 must be -9 over 9, which equals -1. Is it good that y equals -1 here? Yep, it is. That checks. So I did it right. This is the equation of the line through those 2 points. Okay, it looks like a lot of work because it is. You get it wrong the first time, try again. These are challenging problems. The only reason I get them right on the first time is, well, experience, and sometimes I get lucky. All right, let's see. I accidentally added an extra slide there. That can go. We want this one. Okay, find an equation, y equals mx plus b, for the line who is sketched below. Well, some things of note here is I seem to have the y-intercept right there. So that means b has to equal 2. That's nice to know. Got that one. To find the slope, I have to identify 2 points and figure out how to get from here to there. So I'm pretty sure I'm dropping 2 and I'm running 4. So the slope, m, is -2 over 4, which can be more simply written as -1/2. So I believe the equation here is y equals -1/2 times x plus 2. To double check that that's the equation, I'm going to estimate another point on this graph. It looks like I have the point -4, 4. So I'm just going to check by plugging in -4 and seeing what happens. So check. Y equals -1/2 times -4 plus 2. Negative times a negative is positive. Half of 4 is 2. Plus that 2 over there gives me a 4, and that's the point right there. -4, 4 appears to be on this graph. So my line agrees with that. So now I am double sure this is the right equation for that line. I hope this was helpful. Do good math. Stay in touch. See you later.